Okay, there it goes. All right, so here is my example. It's kind of simple, but so you can, when you start out down the road of trying to answer a question using science, a lot of times it's going to start with an observation. And so in this case, this is just an example of a broken flashlight, or your flashlight doesn't work. So that's the observation. The flashlight is not working. And so your question ends up being, why doesn't the flashlight work? Why do you even care about that? You want your flashlight to work. So you have a good reason. So your two hypotheses just come from what seem like normal answers that you would come up with. The batteries are dead, or the bulb is burned out. So hypothesis 1, the batteries are dead. Hypothesis 2, the bulb is burned out. And then your predictions are either replacing the batteries will fix it, or replacing the bulb will fix it. And then your experiment, in this case, your test of your hypothesis, is just either replacing the batteries for hypothesis 1 or replacing the bulb for hypothesis 2. And so if you were going to turn that into an if-then statement, how could you write hypothesis 1 as an if-then statement from there? If
the batteries are dead.
Okay, so if the batteries are dead, and I replace the batteries, and this is going to get really long, and the flashlight works. Hold on, I'm going to make it more simple. Okay, so if I replace the batteries and the flashlight works, then what?
Your hypothesis is right.
Yes, then hypothesis 1 would be accepted. Or you could say, then the dead batteries were causing the flashlight not to work. Okay? So then you would accept that hypothesis. You could say, if I replace the batteries and the flashlight still doesn't work, then what?
Then it could be the bulb.
Then it could be the bulb, but then you're also going to reject this hypothesis. So that goes into the predictions. You can have two. You can have one for if the hypothesis is true, and then have one for if the hypothesis is rejected. Does that make sense? This is going to come up in that lab, and I just kind of want you to get your mind thinking in that way. A lot of times people struggle to come up with this. It's not that complicated, but it's just a different way of trying to wrap your head around it. Okay, so if the results of your experiment are, you replace the batteries, the flashlight still does not work, then you're going to reject hypothesis 1, and you're going to come over here and test hypothesis 2. So hypothesis 2, bulb is burned out. So if I replace the bulb and the flashlight works, then I'm going to accept hypothesis 2 that the bulb is burned out. Does that make sense? If I replace the bulb and it still doesn't work, then what are we going to do to hypothesis 2? I'm going to reject it. Something else. Maybe the flashlight's it's over. It's gone for good. Okay. So the experiment or test of your prediction is you replace the bulb. The results are the flashlight works and the hypothesis is accepted. Does that make sense? I know it's a very simplistic example, but so usually you're going to have at least two predictions. One for if the hypothesis is correct and one for if it's not. When you very first learned about hypotheses, what does everyone say that a hypothesis is? What did you say? A scientific guess or an educated guess, yeah. So, and it kind of is because you kind of come up with them based on your knowledge of the world or maybe some other research that you've done to kind of figure out what the possibilities would be. So, okay. All right, we're almost done with this chapter. All right, the main requirement for a scientific hypothesis is that it needs to be What? Testable, yes. Okay. So I'm just going to go through a few terms related to experiments. So independent variable, dependent variable, controlled experiment, and control group. So what is the independent variable in an experiment? Someone said something I couldn't hear. So the independent variable is the variable that's manipulated in the experiment. So that's the one that you're testing. The one that you're asking your question, and that's going to changing that variable in your different experimental groups is what is going to help answer your question, hopefully. Okay, so usually the independent variable is what you're measuring. Does that make sense?
Yes.
A lot of times it'll seem clear, and then when you try to use that information later, it gets confusing. So what's the dependent? Oh, yes, what is the dependent variable? Sorry, I'm just making sure I'm going the right order. You know what? I just did tell you. So, okay, it's not. I'm sorry. It's not what's being measured. What is the dependent variable? It's a rough start back here. So, what is the dependent variable? Someone said it.
Depends on the independent.
It depends on the independent. It is what's being measured. I'm sorry. I don't know why I said that. It's fine. What is being measured in the experiment? So that's your data. Okay, so the independent variable is the thing that you're changing, and then the dependent variable is your data. It's what you're measuring. Usually, sometimes you have to make calculations or whatever to try to, come up with your data, but in general, it's what's being measured in the experiment. Okay, so then we're going to talk about control group versus controlled experiment. What is a control group usually?
The one that's not changing.
The one that you're not changing. So you have your control group and your test group or experimental group. Sometimes you have multiple. You can have more than one control. You can have more than one experimental group. But the control group, usually the way that I explain it is that it is at standard conditions. And what I mean by that, I'll give you some examples in a minute. And then a controlled experiment is an experiment where you compare one or more experimental groups to a control group to try to see if there's a change or if there's a difference. And in a controlled experiment, you control or make the same all of the variables except for the independent variable. Because if you don't, what is the problem? If you're not making everything the same except for the one that you're manipulating, what's the problem?
It won't be supported.
Yeah, you won't know if you're seeing a difference because of the thing you're manipulating or for some other reason. And I'll do an example to explain that more. Controlled experiment. Comparing experimental group to at least one control group. So, if I wanted to figure out how much fertilizer would be the best amount of fertilizer for me to apply to my tomato plants, I might set up an experiment. And so I want it to be a controlled experiment because I actually want to answer my question. I don't want to just have meaningless numbers. And so I might ask the question like this. How does increasing and you can get really specific with these questions, or you can be sort of general, but how does increasing the amount of fertilizer affect the growth rate of my tomato plants? Okay. That would be a question. That's probably a question we can come up with a hypothesis and test it. So, what are we going to do? We need a control group. How are we going to figure out what to do to the control group?
Recommended?
Yes. Yep. Very good. So for the control group, you might have one control group where you're just using whatever the published recommended amount of fertilizer to apply is, or whatever it says on if you are using some kind of commercial fertilizer, you can use whatever it says on the bottle. So, I always misspell recommended. I don't know if it has 2 M's or 2 C's. I know it's only one of them. Fertilizer, recommended amount of fertilizer, okay? And then, so say that is 5 milliliters per gallon times 2 times a week, okay? Then we might want to know how increasing that amount would impact the growth rate. We might also want to know, like, maybe I could get away with using half the amount and save money. So you could do several different, you could do 2.5 mils per gallon. Now I'm mixing English. Mils per liter, we'll say. Or actually, it's probably going to be whatever. We're using liquid fertilizer. Mils per liter times 2 times a week. We could do 10. Whatever we think is appropriate. And we'll probably, if you were going to do this, you would probably read some other people's experiments and try to figure out what seemed reasonable. Okay? What might another control group look like if we wanted to do another control? Just don't apply any fertilizer. Why would you want to have a control group like that? Yeah, I mean, you could see if it has any effect on it at all. You can also, there might be some problem with the batch of fertilizer that you're using or something. So if you see any kind of differences, you want to, make sure that it's attributable to the fertilizer. Okay, so in this experiment, we're going to measure the rate of plant growth. We're just going to measure it in centimeters per day. We're just going to measure all our plants once a day. So that's going to give you the growth rate. What is going to be the independent variable in this experiment? The amount of fertilizer, specifically the amount of fertilizer. We could do a different experiment where we compare types of fertilizer, and then it would be the type of fertilizer. What's the dependent variable? The growth rate of the tomato plant, specifically the growth rate of the tomato plants. If you just say the tomato plant, it's almost there, but not quite. Okay. I think there's one more thing. I think that's it for this. Oh, I know. There was one more thing I was going to say. So one more thing is that we talked about in a controlled experiment needing to make sure that you're only changing the independent variable. So what are some other things that we're going to need to do in our experiment to make sure that it's a good experiment that's going to answer our question?